Okay, so from what we talked about today, and you might want to get your memo page out and write on it. So we have sine, cosine, tangent. And we have degrees and radians. 3, 4, 5, 6. 1, 2, 3. 3, 2, 1. 3, 1, 3, 3. Divide these by 2. And square root. I'm guessing a lot of you use the IOU chart, but I also just use this with any radius. Like if the radius is 5, I'll look at the point 5, 0, 0, 5, negative 5, 0, 0, negative 5, just to make a point. Lots of times people use a radius of 1, and then all of it reduces down to the same. But if you remember what we saw today, if you're measuring by whatever this radius is, this will be 1, 2, 3.14 radians. So this is pi, and then we divided it in half. Pi over 2 is just like 90 degrees. 3 pi over 2 is just like 270. Now if I cut it into fourths, if this is 180 and this is 90, we learned that these pi over 4s What's interesting, this is 1 pi over 4, 2 pi over 4 reduces, 3 pi over 4, 4 pi over 4 reduces, 5 pi over 4, 6 pi over 4 reduces, 7 pi over 4, 8 pi over 4. And so all of these that don't reduce give you 45 degree angles, pi over 4s. So with 45 degrees, you have pi over 4. So you can go ahead and put that in your table. And then we divided it into 6 equal parts where I counted by 30 degree increments. 15 degrees on either side of these 45s. And so this was pi divided up into 1, 2, 3, 4, 5, 6, and so on. So this is pi divided by 6. All the way over here, this next one is 2 pi over 6. This next one is 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. This one is 8 pi over 6. 9 pi over 6, 10 pi over 6, 11 pi over 6. So in purple, these ones that are over 6 are all 30 degree reference angles. Pi divided by 6 is like 30 degrees. And then these, pi over 3s, everything with a pi over 3. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Those are all 60 degree angles. Sorry, that should be a pi over 3. Now you shouldn't get these confused because, you know, if you're translating, pi is 180 degrees. And 180 divided by 3 is 60. Pi is the same thing as 180 degrees. Divided by 6 is 30. So you should remember those that way. So if you want to take a minute and pause the video, you can put these in your chart. Fill in your radians. And by your IOU chart if you use it, I'm not going to fill the whole thing in, but you've got degrees with sine, cosine, tangent, and radians. You had 0, 90, 180, 270. So this is 0 radians. 90 is pi over 2, 180 is pi, 270 was 3 pi over 2. And so those are your quadrantal angles right here. Pi divided into 2 equal parts. And so now you've got your charts updated. And remember, whenever you're pulling something out of either chart, don't forget to check the sign with all students take calculus. Or if you have an understanding of it, that's great. Okay, so I'll be showing you how I actually find these all, and we'll work on those day after day. But I'm just going to start working worksheet 3. Alright, so how do I do cosine 5 pi over 4? I already know it's a 45-degree reference angle. Hopefully you're looking at your chart enough to know that square root of 2 over 2. Now how do I know where this is? Like I know that this is pi, and you do a common denominator. Like in my mind I think of this as 4 pi over 4, which is pi. So I know 5 pi over 4 is in this quadrant. It's a 45-degree reference angle. And I know the cosine of 45 degrees is square root of 2 over 2. And then I know all students take tangent's positive, so cosine's negative. Alright, get your closest multiple of 6. 11 pi over 6 is really close to 12 pi over 6. 12 pi over 6, I'm just thinking in terms of 6's, is 2 pi. And so 11 pi over 6 didn't quite make it there, so it's 30 degrees away. You can think of 11 pi over 6's. That's interesting to look at for a minute. 11 pi over 6's. Pi over 6 is like 30 degrees, so if you translate, just like if you translate the word desk into Spanish, they're interchangeable. That would give you 330 degrees, which is the same thing as what I have right here. So, but to speed it along, you know, pi over 6's are like a 30-degree reference angle. And I know the tangent of 30 degrees, you should be memorizing, is root 3 over 3. You know, you're in the fourth quadrant. 11 pi over 6 is right before 12 pi over 6. All students take calculus, so tangent is negative. All right, negative 5 pi over 4 is going to rotate around like this. Negative means go this way. Negative 4 pi over 4, and then right past it to negative 5 pi over 4. So what I'm doing is what you naturally do. I'm comparing it to pi and 2 pi with common denominators, just like you would compare something to 180 and 360. Like if you had 300 degrees, you usually think of it being 60 degrees away. And so I use those common denominators. It goes really fast. So anyway, I've gone negative 4 pi over 4, negative 5 pi over 4. It's a 45-degree angle. The tangent of 45 degrees is 1. All students, sine is negative, positive, and so tangent's negative. All right, this one we kind of maybe want to go a little slower. It's a 60-degree reference angle. 7 pi over 3. If I go around, this is 3 pi over 3. This is 6 pi over 3. So 7 pi over 3 is back into this quadrant. Pi over 3 is a 60-degree angle. The cosine of a 60-degree angle, or pi over 3, is 1/2. So I've got to flip it over for secant, which is 2 over 1, and it's in the first quadrant. You may want to pause and try to work a couple and then come back and see if you got it right. So let's count to 17 pi over 6. Get your closest multiple of 6. It can be 1 above or 1 below. 18 pi over 6 is the closest to 17. That's 3 pi. So I know this is 1 pi, 2 pi, 3 pi. Here's 18 pi over 6. I'm at 17, so I must have landed right here in the second quadrant. Pi over 6 is 30-degree reference angle. Sine of 30 is 1/2. All students, it's positive. Cotangent of pi. I'm going to think of the tangent of pi, or the tangent of 180. If you want to look it up in a chart until you learn it, that's fine. I think of this point like negative 1, 0 if the radius is 1, or negative 5, 0 if the radius is 5. But tangent is y over x. And so the tangent of 180 degrees, the tangent of 180 degrees is 0, and the reciprocal of that would be undefined. So anything in your chart where you got tan of 180 or tan of pi, and you flip a 0 over, you get undefined. The sine of 2 pi over 3. Closest multiple of 3 to 2 pi over 3 is 3 pi over 3. So 2 pi over 3 falls right here. It's a 60-degree reference angle, square root of 3 over 2, and sine is positive in that quadrant. All right, so think of the closest multiple of 3 you can get to 4 pi over 3. It can be 1 under or 1 over. And so I think of 4 pi over 3. The closest thing I can get to is 3 pi over 3. This method will always shoot you over here or over here, which is what we also do with degrees. So I know this is 3 pi over 3, so 4 pi over 3 ventures into the third quadrant. I need the sine of a 60-degree angle, because my reference angle with pi over 3 is 60 degrees. The sine of a 60-degree angle is square root of 3 over 2. I need the cosecant, 2 over square root of 3, and all students take. Tangent is positive, so that means sine and its reciprocal are negative. And then you can rationalize it if you'd like to. All right, moving on worksheet 3, number 9. All right, think of the closest multiple of 3 you can get to 10 pi over 3, which is 9 pi over 3, which is 3 pi. It'll always reduce to one of these two places, these two places. All right, so if I go 9 pi over 3, I will have gone pi, 2 pi, 3 pi. It's 9 pi over 3, so 10 pi over 3 pushes past it to a 60-degree reference angle. Cosine of that's 1/2, and in the third quadrant, cosine's negative. Sine of 3 pi over 2, these are our pi over 2's. This is 1 pi over 2, 2 pi over 2, 3 pi over 2's down here, where I think of the point 0, negative 1, if the radius is 1. Sine is y over r, so that's negative 1. Or it would match up if you filled in your chart, your IOU chart. All right, this is a good one. You got to think about a lot here. All right, the closest multiple of 6 is negative 6 pi over 6. So negative pi goes this way. This is negative 6 pi over 6. So negative 5 pi over 6 must not have made it there. So I'm right here. Pi over 6's are smaller. There's 30 degrees. It's pi divided up into 6 parts. And I know the cosine of a 30-degree angle. The cosine of this 30-degree angle would be square root of 3 over 2. Flip it over, 2 over square root of 3. And cosine would be negative in this quadrant, so its reciprocal is negative. So this negative actually doesn't have anything to do with that negative, or it doesn't mean it's going to be negative. Like you go in the negative clockwise direction and end up somewhere where it should be positive, so be careful that you know what quadrant you're in. Closest multiple of 6. You'll learn to do this in your head. 6 pi over 6 is pi. 7 pi over 6 is 30 degrees past it. Sine of 30 degrees is 1/2. All students take. I'm in the third quadrant, so it's negative. Again, you'll start to get better and better at this. I'm going to find the tangent of 90 degrees, or pi over 2, right up here. I use a point. You can use your IOU chart. It works whether you have 0, 1 or 0, 4 with a radius of 4. Either way is 0, 7 with a radius of 7. It doesn't matter. But you can use 1 if you like. I know that tangent is y over x. So that would be undefined. And the reciprocal of that would flip it over like this, and so this would be 0. The cosine of 5 pi over 3. The closest multiple is 6 pi over 3. Which is 2 pi. So 5 pi over 3 didn't make it there. It's a 60-degree angle. Cosine of a 60-degree angle is 1/2. And if you don't like to see, this, all students take calculus that we derived, cosine is x over r. I know x is positive. All right, this one's going backwards or clockwise. So this is negative 4 pi over 4, negative 4 pi over 4. Takes me to negative pi, and then I push past it to negative 5 pi over 4. 45-degree angle. The sine of a 45-degree angle is square root of 2 over 2, and it's positive. Another way to know it's positive is to understand sine is opposite, or y over r is positive. When you flip over square root of 2 over 2, you just get square root of 2. Number 16, you should maybe pause and try some of these and then check your answers. Tangent of pi. Just a point negative 1, 0 with a radius of 1. Tangent is y over x, so it's 0, or you can look it up in your IOU chart until you memorize it. Negative 7 pi over 4 is really close to negative 8 pi over 4, which will be negative 2 pi. That's negative 8 pi over 4, so this didn't quite make it. This must be negative 7 pi over 4. 45-degree angle. In the first quadrant where its cosine is positive, your x value would be positive, and that's just root 2 over 2. All right, secant of 13 pi over 4. By the way, there's this word coterminal, negative 7 pi over 4. Going all the way around this way is coterminal with pi over 4 going this way. So this has a coterminal angle. Your closest multiple of 4 is 12, which takes me to 3 pi. 1 pi, 2 pi, that's 12 pi over 4, so 13 pi over 4 goes into the third quadrant. The cosine of a 45-degree angle is square root of 2 over 2. Flip it over and check the sign if you like this. Tangent's positive, so I know that cosine was going to be negative. Remember, when you flip this over and rationalize it, you just get negative root 2. This gives you 2, and that just cancels out. And coterminal. This wraps around to negative 13 pi over 4. It's coterminal with just negative 3 pi over 4, or positive 5 pi over 4. Okay, sine of 13 pi over 6. So the closest multiple is 12 pi over 6. You'll get to do this in your head. It's 2 pi. 13 pi over 6 goes past it, a 30-degree angle. This one's 1/2. Cosine of 2 pi over 3. This is close to 3 pi over 3, which is pi. So 2 pi over 3 is up here at 60 degrees. Cosine of 60 degrees is 1/2, but it's negative in that quadrant. All students. Cosine would be negative, or another way to think about it if you'd like to understand it and just do it that way, your x component or adjacent side is negative.